sir, my seminar guide Dr. Brajesh Tripathi sir, seminar coordinator D. Sharma sir, faculty members, examiners and batchmates. I am Sunil Kumar Yadav, pursuing my BTech from University Department of Mechanical Engineering, Rajasthan Technical University, Kota, Rajasthan. Today I am going to present my seminar topic on solid-state batteries in vehicles. So let's start with the first slide. So before talking about the solid-state batteries in vehicles, let's first talk about what is solid-state battery. So a solid-state battery is a technology that uses solid electrodes and a solid electrolyte instead of a liquid or polymer gel electrolytes found in lithium-ion or lithium polymer batteries. The solid electrolyte in a solid-state battery plays the role of separator as well. Let us see the working of solid-state battery. The working of solid-state battery is quite similar to that of lithium-ion batteries. The anode and the cathode of the batteries are made up of an electrically conductive material. An electrolyte is present between the two electrodes that contain the charged ion particles. The lithium ion moves from the electrolyte between the electrodes. The movement of charged particles in a particular direction produces current. When the ion moves from cathode to anode, that is from the positive electrode to the negative electrode, it is said to be charging. Similarly, the movement of ions in the reverse direction, that is from the anode to the cathode, discharges the battery and supplies the load. Now I will talk about the difference between the solid-state batteries and the conventional lithium-ion batteries. Let's discuss briefly the solid-state batteries having a solid electrolyte, whereas the conventional lithium-ion batteries have a liquid electrolyte, and that is lithium-ion or polymer gel electrolyte. They both have solid electrodes, and as compared to the conventional batteries, solid-state batteries have higher densities. I mentioned some advantages of the solid-state batteries, which are a solid-state battery has higher energy density than a lithium-ion battery that uses liquid electrolyte solution. A solid-state battery doesn't have a risk of explosion or fire, so there is no need to have component for safety, thus saving more space. A solid-state battery can increase energy density per unit area since only a small number of batteries are needed. In present, we are using the solid-state batteries. Like in solid-state batteries are highly used in medical devices such as pacemakers, defibrillators, etc. A number of gardening tools and equipment such as lawnmower, etc. make use of solid-state batteries. Aerospace and satellite generally use solid-state batteries to power various gadgets and devices because they are light in weight and are non-flammable. Solid-state batteries are highly used in smartwatches and small toys. Now let's discuss the need of solid-state battery in electric vehicles and how it is going to help us to move from combustion engine vehicles to the electric vehicles. Solid-state batteries are capable of delivering 2.5 times more energy density as compared to lithium-ion batteries. Solid-state batteries are comparatively more durable and safe. Solid-state batteries are comparatively less expensive and compact in nature. The greater electrochemical stability of solid-state batteries makes them more reliable. Solid-state batteries are comparatively lighter in weight. The recharge rate of the solid-state battery is 4 to 6 times more than the regular batteries. Instead of so many advantages of solid-state batteries, there are some problems plaguing them, like the mass production and manufacturing of solid-state batteries are quite complex. Research regarding solid-state batteries is still in progress, and the perfect material for the electrolyte with an ideal ionic conductivity is yet to be found. And also the accumulation of lithium dendrites after a number of charge-discharge cycles. Speaking of problems, the main reason we are not seeing a solid-state based electric vehicle is that the dendrite formation. The dendrites are tiny rigid tree-like structures of lithium metal that can grow inside a battery. Their presence reduces battery life and performance and can lead to short circuit and catastrophic battery failures. The automakers are trying hard to develop a solid-state battery for electric vehicles. The list of automakers developing a solid-state battery for electric vehicles are Japan's Toyota Motor Corporation. It is one of the front runners of mass production solid-state batteries. Toyota has also teamed up with Japan's Panasonic Corporation to develop these batteries with the Prime Planet Energy and Solution Inclusive Ventures. Germany's Volkswagen has invested in the US battery firm Quantum Scale Corporation, which is backed by Bill Gates. Stellantis, which was formed by the merger of Italian-American automaker Fiat Chrysler and Francis PSA, has a venture called Automotive Sales Company. with Total Energies and partnership with China's contemporary Anthrax technology, Co Limited, Ford Motor Company and BMW Auto Groups have invested in startup Solid Power. South Korea's Hyundai Motor, which has invested in startup Solid Energy System to mass produce solid state batteries in the year 2030. Samsung SDI Co Limited, which is an affiliate of Samsung Electronics Co Limited, is also working on developing these batteries. With that, I conclude that solid state batteries have the potential to be safer and they have potential for higher energy densities. This means for electric vehicles, you could go further in between charges or need fewer batteries for grid scale energy storage. The addition of liquid electrolyte may help bridge the gap of commercialization without sacrificing safety. With successful development of solid state batteries, and if we can produce the solid state batteries in mass production, then we are going to see less expensive and affordable electric vehicles with long running range. As many countries are aiming for ban of vehicles that run on combustion engine, in that case, solid state batteries can help us by providing a long running range, making a vehicle safer than conventional battery vehicles, and by taking less time while recharging it, so that people can use it as a primary vehicles. That is all by my side. If you have any question regarding this topic, you may ask.
Yes, what are the most challenging technological aspects regarding scalable production methods of solid state batteries?
Okay. It is important to produce solid electrolyte that can pack tightly but remain flexible, so that the ions and electrons can flow easily while the anode has room to expand and contract. Minimizing the deformation of the electrolyte is decisive, as this influences the long-term performance degradation of the battery. Is there any other question?
Yes. Are there any downsides?
Yes, there are some downsides. A key challenge is the lithium-ion transport through the solid electrolyte and in particular over the interfaces with the electrodes. The resistance to the electrode, respectively solid electrolyte interface, is too high, impeding fast charging and discharging. Volume expansion in intercalation material is also a significant barrier to solid state batteries. If the battery expands or shrinks a little, there is a risk that the surface contact will break off, so that there is no more charge transfer. Is there any other question?
No.
Okay, then I conclude here. I hope you all have enjoyed the session.